Good morning, dear students. Let's complete what we have studied before about variation. This is the second partition of the lesson. Um, say whether x and y show direct variation, inverse variation, or neither. If I want to know if this relation is direct or inverse variation, I have to write it in another way, as it's a relation in one variable here. It's x equals or y equals. So we have to solve the equation for y and take note this the relationship. If I make it over x here and over x there, and this x will be cancelled with this x, so the answer is y equals 4 over x. You note that this relation is inverse variation. For letter B, y equals x plus 4, no adding or subtracting in variation. So this relation is not inverse or direct variation. Okay, x equals y over 4. If we make cross multiplication y and solve the equation for y, so y equals 4x, as you notice that this is a direct variation. Okay, letter D, x over 3 equals 4 over y. If we make cross multiplication and take a relation at x equals, so it will be 12 over y. As you see, if you make cross multiplication, this will be x y equals 12. Then we divide both sides by y, so the relation will be x equals 12 over y, and this is inverse variation. Okay, letter E, y over 5 equals x over 2, and we make cross multiplication. We have y equals 5x over 2, and this is direct variation. Last one, we solve the equation. It's a trinomial, and it's a square trinomial. And if we factorize it to two parts, it will be x power 2y minus 7 multiplied by x power 2y minus 7 equals 0. And so this bracket, or this one, both of them equal 0, so x power 2y minus 7 equals 0, and we move x squared to next side, and we find the relation, which is x power 2 equals 7 over y. I'm sure this is an inverse variation. Okay, a new vocabulary here. We have a joint variation. We say that y varies directly as x and z, then y equals kxz. Or if we write it as y varies inversely as x and z, then y equals k over xz. And let me remind you that this k doesn't equal 0, and we call it the constant of variation. Example, find the relation of variation where w varies as x, y, and z, where w equals 36, x equals 3, y equals 5, and z equals 6. Okay, let's write the relation. W equals kx, y, z, because w varies as x, y, and z. Now we have to get the k, so we replace by these values. So w is 36, x, y, z, they are 3, 5, 6 respectively. So we find k, we multiply 3, 5, and 6. So 36 equals 90k, and divide by 90 both sides, so k equals 2 over 5. And the relation will be w equals 2 over 5 x, y, z. This is the relation that we have to find it. Next, find the relation of variation where q varies inversely as r and s, where q equals 2, r equals 1, and s equals 3. The relation, because q varies inversely as r and s, so q equals k over rs. We replace q rs by the values 2, 1, 3. Then we find the value of k, which is 6, and we write the relation q equals 6 over rs. A new vocabulary we have here, it's combined variation. We say y varies directly as x and varies inversely as z, so we write the relation as y equals kx over z. where k is the constant of variation. Okay, write the relation. Y varies directly with x and inversely with z power 2. How can we write this relation? Yes, it's y equals kx over z power 2. This k is the constant of variation. Y varies inversely with x power 3 and directly as x. So we write this as y equals kz over x power 3. Y varies directly with x power 2 and inversely with z. How can we write this? Yes, it's y equals kx power 2 over z. Z varies with x power 2 and z and y, so we write it as z equals kx power 2y. And finally, y varies inversely with x and z. We write it as y equals k over xz. A new question. Find the relation of variation where p varies directly as q and inversely as r, where p equals 0.064, q equals 16, and r equals 5. First, let's write the relation. P equals kq over r because it's inversely as r. Replace the values. Solve the equation to find the k. And now write the relation. Another question. C varies directly with the square, and the square means power 2, doesn't mean square root of m, and inversely with w. How can we write this? Yes, C equals km power 2 over w. You remember the second step? Yes, we replace the letters with 9, 6, and 2. Now, solve the equation to find k. Now, write the relation. Check if the question needs something else. Yes, find C when m equals 10 and w equals 4. So we replace m by 10 and w by 4 to find C. And C will be 12.5. Direct variation uses another rule. Let's see this example. Fill the table. X is the parameter of a square and y is the side length. Remember the rule of the parameter of the square? Yes, x, which is the parameter, equals 4y. So if x equals 4, y equals 1. If y equals 3, so x it's 12. If y equals 6, so x equals 24. And if x 44, y will be 11. As you see, this relation is direct variation. So we have the title here, which is direct variation. We have another rule for the direct variation, and we can deduce this rule by this table. Let's find x1 over y1. The answer is 4. What about x2 over y2? Yes, it's 12 over 3, which is 4. What about x3 over y3? Yes, 24 over 6, which is 4. And finally, 44 over 11, which is 4. Remember that this 4 is the constant of variation. So we have a rule here that x1 over y1 equals x2 over y2, where x1 and y1, x2, y2 are the values and their corresponding values for this table. And if we make cross multiplication, we can change this proportional to x1 over x2 equals y1 over y2, or we can write it as y1 x2 equals y2 x1. Another example to find another rule for inverse variation. Read the example. Fill the table. X and y are the dimensions of rectangle of area 12 centimeters squared. Remember the rule of the area of the rectangle? Yes, length times width, or the product of the two dimensions equals the area, which is 12. As you notice, this relation is an inverse variation because if you divide both sides by, for example, x, and divide there by x, so the relation will be y equals 12 over x, which is inverse variation. Okay, let's fill the table. If one of these dimensions is 12, so the other is 1. If one of these dimensions is 2, so the other is 6. And if one is 4, the other is 3. If one is 2, the other is 6. If you find x1 over y1, the answer is 12. x2 over y2, the answer is 3. x3 over y3, the answer is 3 over 4. And x4 over y4, the answer is 2 over 6, which is 1 over 3. So the inverse variation have doesn't or it's haven't the same it hasn't I'm sorry the same rule of the direct variation, because x1 over y1 doesn't equal x2 over y2. But if we find x1 times y1, the answer is 12, and x2 times y2, the answer is 12. x3 times y3, the answer is 12. x4 times y4, the answer is 12. So we can write a new rule for inverse variation, which is x1 y1 equals x2 y2. Or we can make it in a proportional way, so x1 over x2 equals y2 over y1, or x1 over y2 equals x2 over y1. This is the uh, the variation lesson. Thank you very much, dear students, and bye-bye.